In this video, we look at an R script that runs a little simulation of rolling two dice, and it's going to roll those dice until it achieves a snake eyes, both simulated die being ones, or the sum being two, and then it counts up how many rolls it took to get that result, and then it performs many samples of that process, and then does statistics on those roll counts. Here we have in line 5, just establishing the sample size, the number of samples we're going to do. In this case, we're choosing 10,000. And then in line 8 here, we are just making room for our results. So we're going to have an integer vector that of that number of samples. So for each position in this thing, we will have a number of rolls that it took to achieve snake eyes. Starting here in line 11, we are creating a for loop over the samples. So we're going from, we'll introduce a counter I, and we're going from 1 up to including the sample size. Die sum is for the sum of the two die, and we're setting it here to 0. Basically, just anything that is not 2. Our while loop is going to say, while the sum is not equal to 2, continue. And so we want to get into that while loop in our first time around. So we just need the die sum to be something other than 2. And then that was line 12. Line 13 is that we are counting for a given sample. We're counting the number of times it takes until we get snake eyes, and so the count starts off at 0. And then in 14, we begin our while loop. So a while loop is for when we don't know how many times we are going to need to repeat something. So in 11, we started a for loop. We know that we are going from 1 to sample size. So when we know the number of loops, we tend to use a for loop. When we don't know the number of times we'll be repeating, then we tend to use a while loop. And we don't know how many times we're going to have to roll until we get snake eyes. It could be on the first roll. It could take hundreds of rolls. Okay, so we have a while, the keyword while, and then in parentheses some condition, and we will stay in this loop so long as the sum of the two dice is not equal to 2. That explanation equals means not equal. So long as that condition is true, that the die sum is not equal to 2, we will keep doing what's inside the while loop, and the while loop begins at 14 and ends at 18. And so what we're doing, we have 2 lines of code in the while loop. One is line 15, where we are simulating the rolling of the 2 dice. So break this down a little bit. Sample is taking a sample from the range 1 to 6. It's taking 2 samples, and it's allowing for replacement. So if my first sample is a 4, then 4 is also available to get me 2 4s, and I need that because what I'm looking for is 2 1s, so I definitely need replacement. So this is the 1 to 6 makes it like dice, like we're simulating a dice. The 2 makes it 2 dice, and replacement is also part of simulating dice, that the 2 dice can have the same value. Then we are summing them and assigning that to this die sum, which we use in our condition, and we are incrementing the counter. So R does not have a simple sort of plus incrementer, so we're doing the count equals count plus 1 type of incrementing. And then when the condition, when finally we roll a snake eyes, 2 1s, and the sum is 2, then this condition will become false and will come out of the loops, out of the while loop, and then we will assign that sample, that element in our roles vector that count, and then we will begin the for loop again, or go back to the beginning of the for loop and continue to move through our samples. When we finally finish with all of our samples, and this is enough samples that you're going to see at least some delay, but when we're done our samples, we're going to do a histogram of roles, and then we're going to do some statistical summary of those results. So that's going to be mean and so forth, mean and median and third and first quartiles, things like that. Okay, so let's run this sucker. All right, take a little while, then there we go. So the last count was 28. Our last sample, it took 28 rolls to get snake eyes. Our sample was 10,000. Here's this great big vector of 10,000 samples. We see it's 16, 49, 66, 3. It's got a fairly wide distribution. We see that here in the histogram, that their values, their samples that took up to 300 or close to 300. And here is our summary statistics. So the minimum was 1. So in one of these samples, it took only 1 roll to roll snake eyes. The mean is about 36. And here's the median is smaller because it's the median and the mean are not the same. You can obviously see this is a fairly skewed distribution. And here was the maximum of 285. And if you want to see, this will be different numbers, a different sample, but we can also, instead of doing a histogram, we could do a box and whiskers plot. And let me save that and then run this. And there we go. That there's down here is the main box and the whiskers, and then there are lots of outliers of this. It had that very long tail. That meant that there are lots of outliers in this distribution. And this time, the previous maximum was 280 or something, 285 or something. And here it's larger. So there's this very long tail with rare but large numbers of rolls taken. Occasionally happens. All right, so just some playing around with R script. In other languages, this program would take longer, but sort of R handles certain things, especially all these statistics. They're just all built in because that's sort of what R is for. So you can do this in other languages, of course, but it's just given the nature of R, this is a fairly short little program in R. All right, thank you for your attention.